Hey guys, by now I hope you are all pretty familiar with Chapter 2, which is motion. And if you are not familiar with it, of course, go back and watch all my videos on it. I think I have about 4 or 5 videos on it. This might be my 5th installment. And this is kind of a wrap-up video for Chapter 2, motion, because in this video I'm going to be doing some examples from your homework, from the review questions, RQ, and the plug and chug, PNC, and think and explain, right? So these are the ones that you will often get assigned for homework. So it's good that I'm going to do a few of them in the video so you know how to go about solving them and whatnot. So let's go ahead, and I haven't really planned this video out. I'm just going to go through. I'm looking in the book right now, so looking at your homework assignments, the exact ones that you get. I'm just going to pick a few good questions out here. So let's take review question number 2. Speed is the rate at which happens. Speed is the rate. Remember rate? Remember rate? Rate was a key word that we talked about in the first motion video, I think. And it always means something's divided by time, right? It's divided by time. Divide by time. The rate at which what happens? At which what happens? All right, well, let's think about this. What happens? Well, if we remember our speed equation, speed is equal to distance over time. This means it's a rate, right? This guy right here means it's a rate because it's divided by time. But we don't want to say speed is the rate at which distance is divided by time. That's just weird, and it's not. I mean, it's weird because we're repeating two things. It's the rate. Rate already means it's divided by time, so we don't want to repeat that. So what we're gonna say, it's pretty intuitive when you think about it. Speed is the rate. So rate, when it says rate, it already encompasses this divided by time. So speed is the rate at which distance is covered, right? Covered. Okay? Sorry, it's a GD thing. I don't know. I did G, but it's not G, so covered, okay? So if you think about it, it's pretty simple. Sorry about my phone. It's pretty simple. If we have a car moving at 300 miles per hour, then that is a speed. That's a rate, and he's covering distance. It's distance over time, right? So he's covering a certain amount of distance. We can also say change in distance. This little delta sign here. It's the Greek numeral or Greek character delta, which means change in science. I think it means something else. Yeah, it has various meanings. I think it's something else in chemistry. So yeah, that's change. And so speed is the rate at which distance is covered. So keep that in mind, and we'll move on now. Let's see, just get our palette back to black here. Whoops. Okay, so now we're going to move on to another review question because I think review questions are very helpful. So let's see, what's a good one? Okay, let's see. What is number 11 in review questions? What is the acceleration? I'm going to abbreviate it with A. What is the acceleration of a car that travels in a straight line? Of car that travels in a straight line at a constant speed of 100, is that 100? 100 kilometers per hour. Of 100, sorry, 100, well, that looks like that's just all bad. 100 kilometers per hour, okay, per hour. What is it? So let's look back to our acceleration. Acceleration is equal to change in velocity, right? Okay, so that's key. That's a key. That's something very important to realize. So now to really get a good definition of acceleration, we want a good definition of velocity, right? Because that's another key term. So velocity is change in is, or not necessarily change, but change in speed or direction, right? Magnitude and direction. It's a vector quantity. Okay, so to answer this question, we have a straight line. This is a key term that we want to identify, and we have constant, which we want to identify. Okay, so we look at this and we say, okay, straight line, no change in direction, no change in direction, and we have constant, no change in speed. So what's the acceleration? If there's no change in velocity, none equates to 0. The acceleration is 0. I know it sounds weird because 100 kilometers an hour is, it's a good speed. It's pretty fast. But it's weird to think that really you say that acceleration is 0. In common language we'll say like, oh wow, that car is accelerating very fast or something like that. But really, if it's moving at 100 kilometers per hour in a completely straight line, which is, mind you, unrealistic, but hypothetically, if it's moving at a straight line at 100 kilometers per hour, its acceleration is 0. 0, okay? So that's a key thing to realize. Now let's do one more from the review questions. I'm trying not to do ones that are very revealing because I don't want to do your homework for you. I know you probably would like that, but I don't want to do that. Because I don't want to take too much away from your class, but this is just kind of a supplement to your homework, just kind of help you out, give you a little push. So, all right, let's use pink now. Now we're going to do number 15 of the review questions, and it says, what's the meaning of free fall? Free fall. What is free fall? So this one's really easy, okay? And I'm just going to tell you straight out. You should remember this, but remember free fall, we're talking about the parabolic paths and whatnot. So the definition of free fall is it's essentially falling by gravity only. Okay, I know that's kind of confusing, but think of it this way: gravity is the only force acting on an object in free fall, okay? So there's no air resistance, no extra boost like rocket boosters or whatever, nothing like that. It's just free fall, okay? Free fall, gravity only. It's only falling at 9.8 meters per second squared gravitational acceleration, okay? So now let's move on to maybe some think and explain. Those are good ones. The video is running out of time a little bit, and I don't want to make it go too long. But let's do a think and explain, because I do like the think and explains. I think the think and explains are very key for your understanding. They kind of move on. Where's a good one? Okay, 41. Says a ball is thrown straight up. I don't want to write this question out. You guys can flip to the page 227 in your book to read it. Number 41 of the Think and Explain. I don't want to write it, take too much time. But it says a ball is thrown straight up. So straight up, right? What will be the instantaneous velocity at the top of its path? What will be the acceleration at the top? Why are your answers different? Okay, so let's think about this. We had a graph. So we in the previous video we did have a graph. So instantaneous speed is the speed at any one moment, any given instant, right? So at the top of our path, I mean it's eventually it's going to go down too. So it has that one instant where it's just sitting up there. It's sitting up there with no movement. So at this point, let's see, the instantaneous velocity at the top of its path, it's not moving down, up, left, right, and it's not moving at a speed, so the instant velocity would be 0 meters per second, okay? Now let's move on to the second part. What will be its acceleration at the top? Okay, well this is pretty simple. Acceleration is the same for any object in free fall, we're talking about free fall here. Always in conceptual physics, we're talking about free fall. So acceleration will be the same at any point in an object's path. It's always the gravitational acceleration, which we know is 9.8 meters per second squared, or more simply 10 meters per second squared. Okay, so those are your two answers. We have, sorry, I did go a little long on this video, guys. We did have instant velocity 0 meters per second, and at the top of the path the acceleration is 10 meters per second, which is weird to think, but that is the answer. So I will see you guys in chapter 3.